Ladies and gentlemen, please take your seats. The program is about to begin. Please welcome to the stage CW4 Tim Reyna, U.S. Army retired Chief Information Officer, Chief Technology Officer, AFCEA International.
Good afternoon, ladies and gentlemen. Hopefully everybody had a good lunch and they're enjoying their day. My name, as you heard, is CW4 retired Tim Reyna. I'm the CIO for AFCEA International, and thank you for being here today. Just before we begin and the panel takes over, I want to make an announcement and just share an upcoming event that I think is valuable for the team in the room. It'll take place in December 3rd to 4th in Frankfurt, Germany, and that is our AFCEA Transatlantic event. I now have the pleasure of introducing the panel of Reprogramming for Resilience, Urgency of Rapid EW Reprogramming. I'm going to hand it over to Dave now.
Thank you. Thank you. Hope everybody can hear me. Good afternoon. My name is Dave May, and welcome to Reprogramming for Resiliency, where we're going to talk as a panel about the urgency of reprogramming in electromagnetic operations. So as we spent the last day and a half here at TechNet, we've had an opportunity to reflect on the importance that the EMS plays in modern combat operations. And our ability to adapt, to innovate, to reprogram is no longer a luxury. It's absolutely a necessity as we prepare for an adaptive adversary. So my name is Dave May. I'm the Senior Advisor to the Cyber Center of Excellence, and I have an esteemed panel with me today. At least I think they're esteemed. Yes, are you guys esteemed?
We'll take that, sir.
But before I introduce them, let me take a quick minute to just define reprogramming in the EMS, in case maybe you thought you were sitting in on a budgeting panel. So at its core, you guys didn't even laugh at my joke. I'm really disappointed. At its core, reprogramming is about updating or modifying our software, our data, our algorithms that govern our systems that operate in the EMS. It's everything from tweaking a sensor so we can better characterize or identify an adversary signal of interest, to perhaps fine-tuning electromagnetic countermeasure so that we are more effective when we apply that technique against our ever-changing adversary. Think of it like reprogramming your navigation app on your phone, right? Imagine that you're in a city with ever-changing traffic conditions. You've got detours, you've got congestions, you've got school zones. If you don't have the latest maps and traffic information, you're bound to get lost or stuck in traffic. And it's like that in the EMS. Without the appropriate software and the techniques, well, we're going to get lost in the EMS and not be able to dominate. So today we have four fantastic panelists. They are all subject matter experts in their field, and they're all going to give you a slightly different perspective on reprogramming. And so I'll take just a second to introduce them. First, we have Colonel Leslie Gorman. She is the Army Capability Manager for Electromagnetic Warfare. Hails right here at Fort Gordon, and she's part of Army Futures Command. She's going to talk to you about the why. Why is reprogramming important in today's modern battlefield? And hopefully in the context of recent lessons learned from Russia and Ukraine. Next, we have Mr. Eric Bose. He is the director of the Army Reprogramming Analysis Team Program Office up at Aberdeen Proving Grounds. He does this for a living. And he's going to talk to you about the mechanics associated with reprogramming, the processes involved, the data needed, the talent. Next, we have Mr. Al Mullenkoff. He's the Senior Cyber Advisor from Army Cyber Command. And he's going to tickle you with the possibilities of artificial intelligence and machine learning as they apply to reprogramming. And then finally, but certainly not leastly, is CW5 Rick Godfrey. He is our Chief Warrant Officer for the Cyber Capabilities Development Integration Directorate right here at Fort Gordon. And he is going to talk to us about the benefits of reprogramming for the Joint Force. So as that as an introduction, Colonel Gorman, I turn it over to you.
Oh, thank you, sir. Good afternoon, ladies and gentlemen. Just want to kind of draw on some of the things we have certainly learned over the past couple of years based on largely the Ukraine-Russian conflict, but then also what we're seeing as we are exercising our electromagnetic warfare operations in our training exercises, and what we're looking at when we are working some real-world operations, CENTCOM AOR, also what our troops face at INDOPACOM as we're projected out on future EW requirements against our pacing adversaries. Some of the things we've learned which certainly apply to reprogramming, is the fact that we are going to require the ability to, in the most agile manner, identify the effect that we want to deliver against a specific target, whether that be military communications, potential counter radar. We're wanting to be able to dynamically determine what that effect is that we need to deliver against that specific signal of interest in space and time to target. And we need to get to the point where it is delivered at machine speed. Some of the lessons learned that we have identified early on, especially during the Ukraine-Russia, is the ability of the Russians in particular to be able to pivot from one capability to another, often on the fly, their ability to leverage commercial or target commercial communications, and then at the same time leverage commercial communications in order to deliver effects. Their ability to, and what they've done, and then also I'd have to say the Ukrainians as well, to be able to quickly scrum up a drone swarm and deliver multiple effects on targets, to literally stun their targeted networks, and their ability to also impact some of the SATCOM communication, the satellite communications that the Ukrainians are using downrange. And so drawing off on these different observations, and then we take a look at, in a very, probably, the European theater in which they're fighting is a more compacted area, but then you take a look at what we're looking at INDOPACOM and the challenges of the distance and tyranny of time, and how that's going to affect how we effectively reprogram our EW sensors and effectors on the battlefield is going to be very critical in future operations.
Eric, over to you.
Okay. Good afternoon, everyone. I know fresh off of Ukrainian lessons learned, talking about AI and EW, I will try not to put everyone to sleep with the mechanics of EW reprogramming. Won't geek out too hard, particularly after lunch here. But Mr. May alluded to the fact that the reprogramming enterprise in the cycle from front from start to finish there, it requires, just as the EMS encompasses multiple domains, so does the EW reprogramming process in regards to multiple functions, and then the skill sets and attributed to those functions. So it starts with the data. Similar to really anything that consumes data, garbage in, garbage out. And so the Intel community is a huge piece of EW reprogramming. And traditionally, historically, leveraged a lot of Title 50 data in terms of EW reprogramming. And now with proliferation of many sensors out there that are sensing the battlefield, as well as to be EW systems in the future as well, have the ability to collect more and more information. And some of those lessons learned in terms of the quick reprogramming cat and mouse game that is required of the Army now need to leverage not only that Title 50 data, but really leveraging as much of the operational based data in near real time that we can. And so the Army is currently kind of working through that right now in terms of leveraging and utilizing such information to inform the EW reprogramming in near real time. From that data, so how do we use the data, is the signal analysis piece. And so this is kind of understanding what that SOI is, breaking down the characteristics of that signal, so for exploitation purposes, as well as modeling and simulation purposes. So we commonly use currently today RF waveform generations based on the intel to mimic that adversarial threat so that we can test particularly ES, for ES-based testing, those systems against that threat to ensure that it's accurately identifying the systems in accordance with the parametrics and the behavior of that signal. And then the exploitation. So once we understand that threat, break it down, have that simulation, have that exploitation, now moving into the actual development. And so there's multifaceted realms of that development. So you have the ES part of it, in which from an ES side right now, there are data libraries or mission data sets. They are largely decision tree based algorithms in which we try to reduce the ambiguities as much as possible so they're accurately representing that threat, particularly in priority of lethality. But moving forward, with the introduction of AI and ML, right, we're preparing to include AI ML based algorithms to be able to detect those SOIs as well. As we are aware that the war reserve modes will be out there and will be activated during times of crisis, and we need to be able to essentially identify or have some reason of confidence interval what these SOIs are in between the known Title 50 reprogramming. And then on the EA side, the electromagnetic attack portion of it, you have that technique development in which that within itself has a broad range of capability where you can just power on force or just dominate via power and kind of obscure comms from that perspective. And then you get into the realms of more finesse and scalpel techniques in terms of low visibility fingerprint walking something off, and then eventually to the RF-enabled cyber where you're now ejecting at the bits level. So various levels of techniques. But then once we have them developed, we need to be able to test them and understand how they're interacting. And that has various formats as well in terms of in the field, in the lab, et cetera. But speaking of the time, as I alluded to earlier, we are trying to do is leverage as much capability within the lab so that we can get the highest fidelity and confidence interval we can with the least amount of time as possible. And ultimately, that level of information will be captured in terms of and placed to the dissemination systems such as Aspen or the EMS arsenal, in which these techniques and capabilities are provided to the soldier with the appropriate level of validation, where some instances will have the actual test device to represent in the labs and/or field tests, and there are other cases where we may just have to leverage physics. And then ultimately actually employing that via the portal and weaponizing it from a soldier capability in the battlefield.
Awesome.
Over to you, Mr. Al.
Okay, hi folks, my name is Al Mollenkoff, Science Advisor at Army Cyber Command. Just to give you some background of something you don't know about how this panel formed. Mr. Dave May and I go way back there, sitting at the end of this panel. He sent me an email and he says, Al, we're doing an EW panel and we'd like to put some Al into it. And I said, sure, hey, as Al Mollenkoff, I'd love to have some Al in your panel. And so Dave May comes back to me and he says, actually, we're looking for a dumb guy too. Do you think you could fulfill that role? So I feel like I'm probably going to be the dumb guy on the panel. So
Go AI Al.
Anywho, the bottom line for AI and technology in general, a lot of times we confuse data problems with artificial intelligence problems.
Yes.
And so what we're going to try to do in the EW spectrum is to try and stay the course and make sure that we keep those two problems in the right buckets. The most interesting aspect about the electromagnetic spectrum is it's infinite. And anybody want to finish my sentence? No. Okay. It's infinite and it's invisible. So that means it's an area that's ripe for instrumentation. And AI is really good at that sort of thing. So there's 5 areas at Army Cyber Command that we think that we can make progress in order to facilitate and accelerate our ability to do our job in the EW spectrum. So the first thing is using artificial intelligence to help neck down and identify signals of interest. You heard my peers here talk about that. Why is AI good at that type of thing? Because it's optimized for looking at patterns and broad scales that humans aren't necessarily good at looking. Another thing, for example, let's just throw out an example of looking for a free copying radar across a vast chunk of spectrum. A human could do that over a period of time, but leveraging AI, we could go a lot faster. identify the free copying pattern, look at and classify the demodulation scheme, and really accelerate the mission overall. Predictive intelligence. So AI can help us to anticipate an enemy's TTPs. And that's really important for us because that helps us to get ahead of the adversary. We talked about automating routine tasks. That's important. Fusing sensor and intel data is another key area for us. Each one of us is like the culmination of how much information our heads can contain and then understand and render in our mind's eye. How much can we truly understand? Well, it's really hard to do for a human, a single individual, but we have the assistance of artificial intelligence to accelerate our ability to narrow down areas of interest, to scope out things that we don't need to pay attention to. I would like to highlight one thing. So for all of you AI advocates out there and experts, and I wouldn't say that I'm an AI expert, more of a good practitioner, but one thing that we consistently see AI is not very good at, it's not very good at handling ambiguity. A lot of times it'll fall down. And so what we shouldn't probably allow is we shouldn't implement AI in situations where it has to make vast levels of decisions that will have ramifications beyond what the scope of the intent was. So based on that, I assess for the near term, AI is probably going to live in the realm of pre-approved actions, where we set up areas where AI can make decisions and execute within very narrow parameters. So thank you. I'm pleased to be here. I appreciate the opportunity, and I'll pitch it over to Rick.
Before you go, Chief, just a bit of color commentary, and I really appreciate, Al, your comments. So Eric talked a little bit about word trace modes associated with adversary systems. And if you're not familiar, word trace mode, so a normal system has a set of signal parameters by which it's normally characterized and identified. And over the decades, thanks to a very robust signals intelligence community, NSA, we have a pretty good understanding of what those signals look like. However, word trace modes mean they can flip a switch and some of those signal parameters change. We don't know what those are because they're reserved for war. But with the proliferation of software-defined radios, we don't anticipate just one set of change. Right. This means that they can dynamically change different aspects of their characteristics at will. And so where AI may be able to assist us is in anomaly detection. So we know what we think we're expected to see. We see part of it, but not all of it. And that can come back and say, well, with 70% certainty, we think it's a target tracking radar or a frequency hopping radio. So we hope that we might get some support from that perspective. But the other challenge with AI, of course, is that, as I'm sure some of you have experienced with ChatGPT and Grok and others, it can be prone to hallucination every once in a while. So it's going to take some sets and reps before our soldiers, our operators, our capability developers, and our commanders become comfortable with this human-machine interaction that we're going to have to work through. All right, Chief, over to you.
All right, so working with the Joint Force. And so while I'm sitting up here while they're speaking and trying to think about, the best way to open this and talk about, why it's important to work with the Joint Force, I think is what I come up with is that it's not just important to work with the Joint Force, it's a requirement. We have to be involved, we have to be tied at the hip to do this. And the primary reason is fairly obvious, right? We fight as a joint force. The Army doesn't go out there and conduct unilateral operations, right? We are always, relying on the other services, and they are relying on us to win these battles. And so when we look at it, you have to have the interoperability level, just like our soldiers on the ground with their man-pack radios that they have can call up and speak to an F-15 or F-16 to get close air support. We need to have that level of integration, interoperability on the EW side as well. And there's a whole host of reasons beyond just interoperability as we get into the details of it, and hopefully we get through more of that as we go through the panel, and I'll speak about it. But we have to understand what we're trying to get to as an end state, right? So if I have a soldier out on the front line, out in the FLOT, and he's got his EW man pack, can that EW man pack speak to the system that's on the aerial platform, whether that's a manned aerial platform, whether it's a UAS, whether it's a balloon, and receive the updates, receive the reprogramming to update their little arsenal that they're carrying as their combat load, so that they can affect the enemy without having to go all the way back to wherever our reprogramming enterprise is going to end, and maybe that's at ARAT, to get that information. Can it be downloaded right there when they need it at the point of need? And at the same time, maybe our soldiers are seeing signals that the Air Force hasn't seen or the Navy hasn't seen, and they can broadcast that back up. So when we talk about reprogramming a joint force, it's very easy to say, hey, we need this, right? Everybody understands it. But the challenges associated with it extend well beyond EW and just EW reprogramming. And if you think about the process to go from the FLOT all the way back to ARAT, who's the official reprogramming center to do this, right? There's a lot of signal communications involved. There's a lot of intelligence analysis that's going to be involved. How do you get this information, this data, and some of its large data sets through these smaller pipes that we have?
Yes.
Whether that's a line of sight communications piece, or whether that's a beyond line of sight, whether it goes into a fiber network somewhere or whatever. But there's everybody at TechNet, and I'm glad to see that we have all these people, and TechNet's a great place for this, are involved in some piece of this chain, right? It's not just EW. There's a lot of vendor booths that I've seen downstairs that involve a lot of this pieces, whether it's security with data at rest, data in transit, whether it's how I access the data. Everybody's involved, and so I'm glad that we're here at TechNet to address all of you with this topic, because I think it's so very important to the Army and the joint community to get this right.
If I can kind of expand a little bit on that, because you really touched on some really good points, Rick. Also, when I think reprogramming, and we talk joint, Army's not always great at doing joint stuff, right? But I think as we are moving into the future battlefield, it is an imperative. And I do think how we approach it from the joint reprogram aspects, we do know that the Navy and the Air Force are very well partnered on joint reprogramming. And naturally, since Army holds ground, right, to your point with reprogramming, to be able to dynamically tip and cue those effects along with, from ground to air, even to space, and vice versa is going to be critical, especially when it comes to the reprogramming effects that we're going to need. And that's just an expansion I see definitely related to your SOI pass off between the services.
And I think that's important. Like the EW's, the workload, the scope of work is largely driven by the SOI.
Yes.
Whereas most systems in the Army, it's specific requirements for that system. When it comes to EW, the majority of the work is actually on the SOI. And so that the threat is the threat, right? That traverses across the services. So if the Navy has cracked the code on something and it has an advanced technique that the Army can use, we should be able to share that seamlessly and employ it.
Absolutely.
Okay, gentlemen and lady, it is now time for some questions and answers. So just to build off of what we just talked about a little bit, I'll throw this to Colonel Gorman and to Chief Godfrey. So what is this thing called the EW Techniques Arsenal? Is it only for the Army or for other services as well? And what are the impediments to allowing DoD to eventually arrive at a place where all techniques and payloads are interoperable across all services?
Oh, that's a great question. I know, Rick, do you want to kick off? Or do you want me to?
Sure.
Go ahead.
I'll take it first. All right. So a techniques arsenal, right? So a place where you get the techniques where you store them. Really, it comes down to how are we maintaining that data, right? Because that's really what it comes down to. And it's a mass amount of data. So it's not just a soldier going in and looking at a Excel spreadsheet and be like, oh, that's the one I need, right? There's just too much. So that's where things like the AI and ML come into it. But when we're talking about sharing that data, it really brings up into we have to have a common language. We have to have a common standard. We have to know that our systems can pass reliable data between the services and between each other and their systems. So having a system that speaks one language and another system sitting right next to it that speaks a completely different language makes things difficult. And previously, we could do plugins or we could do sort of translation softwares. They work sometimes. They don't always work. Things are lost in translation. It also adds cost, adds complexity. And even though it's still at machine speeds, it still slows it down some, right? So you have to be able to have that common language, that common data, if you're going to have a common arsenal that works across all platforms, right? So what that F-16 is using has to be very similar to what TLS-EW is going to use to prevent those not necessarily corruptions of data, but where you just lose and drop things off with data.
No, that's good. No, I think and I would even, so you did a very good job explaining that. I would also extend that to determining where we can share architecture. I think it's going to be a critical piece. And when I say architecture, I'm not just saying Next Gen C2, right? I think there's also, there may be opportunities in the future to be, share pipelines for the code development. I think that's going to be a critical piece, especially when we identify, say, the Air Force, who has a different field of view, right? They pick up on a signal of interest that has not been characterized. But within the Army, on the Army side in the arsenal, potentially, your engineering team may be able to commit some cycles to be able to better characterize that SOI, feed that back into the library. And then to your point, sir, how does that tie back to the arsenal, right? And to be able to leverage the arsenal of effects that in a well-informed manner that spans across all the services, and we're not constricted by time. We are adhering to the standards that you mentioned, but there's potential for shared architecture, cybersecurity standards, right? Because when we think pipelines, it is a common concern for being able to ensure the CI/CD pipelines are secure for that code development as well. So you have the ability to leverage the arsenal across all the forces at different times whenever needed, but then also by leveraging the architecture and then the techniques and the electronic libraries.
Yeah, I think that's a great point. So the collaboration, the focal point of having a portal or a techniques arsenal. So I mean, if you think about how radios have proliferated across the world, there's numerous families, there's numerous versions of each radio. So this arsenal is going to have numerous different countermeasures for each particular version. And trying to keep that all straight might be maddening without having a central collaborative focal point. So.
Yes, sir.
And to add on to that, I mean, there is a need for that right now across services, right? We've had conversations with the Navy on it. And I think some of the other considerations in conjunction with what was discussed is kind of, I always like to think about it as, the kind of Amazon marketplace, whereas, expect to have many different content providers, right, that can contribute to it, just like Amazon has many vendors that contribute to it. But we have to do our due diligence from a cybersecurity perspective, from a quality assurance perspective, to ensure that it's not the wild, wild west and you get some bad actors putting in things that are inaccurate, or intentionally or not unintentionally. So to me, those are additional things that need to be considered over. And potentially even proprietary technique developments by certain vendors and things, and control measures
the
and
UARCs,
access.
FFRDCs,
Exactly.
So Eric, you talked a little bit before about the need for standards associated with data. What types of efforts and experiments have recently taken place that would help us come to a better understanding of the common standards associated with both sensing and effects delivery as it applies to reprogramming?
I mean, we've just operated or concluded, phase 1 and phase 2 of the RF data pilot, in which we worked. I think there was multiple benefits that came out of that. One is looking at the ability to pass data from across multiple organizations within the Army, right? We're not talking joint here, but still, even traversing multiple organizations within the Army, being able to analyze that and kind of mimic that process. And I think a lot of good lessons learned in terms of what is needed from that Title 10 raw parametric, how much, how little, how we identify that. And I think some of the takeaways are there has to be involvement from the Intel community, right? There is, they're doing some of this. They have some filters and some tools and applications that can facilitate a lot of this data analysis rather than us recreating the wheel. And then, secondly, I think it also facilitates the need to, like I said, have those pipelines. And I think we're still needed to kind of put out a capability to the soldier, right? Ultimately, we've done a lot of analysis. We've done demonstrations within, certain organizations. But I think ultimately we have developed a prototype of the arsenal. And to get the next significant learning curve, we need to be able to provide some of that capability directly to the soldier and get that feedback. To me, it's all about that validated learning process and making that a quick iterative turn and enhancing that as we go.
Gotcha. Al, over to you. So what's going to become of our EW effects developers and our operators once AI and ML are integrated into reprogramming?
That's a great question. I think that there's still going to be a lot of need for technical expertise at the human level. We both mentioned how AI can fall down when it encounters ambiguity or something that it hasn't seen before. So let me answer that with a little bit of a story. Let's say you have a group of soldiers who are tasked to go out and they're on a mission to counter an adversary who's using an electronic warfare or electromagnetic warfare system, a radar system, let's say, who's got a very wide free copying pattern. It's going crazy fast. The modulation scheme is hard to pin down. So this team can't quite do that within the time that they have. So they can pull AI into that and identify and classify that demodulation scheme, classify the free copying pattern, identify what the signal is, and then figure out a way to counter that leveraging AI. However, let's say they get sent on another mission where they have never seen the signal before. There's no data on it. The AI is not going to be very assistive to them in those types of situations. So we're going to have to rely on those human experts to help us derive the right countermeasures and accelerate our ability to accomplish the mission, enable commanders to achieve their objectives. We're going to have to do that by, with, and through humans. And we are building experts to do that. And I think you mentioned, Eric, the data pilot. We've got a number of 170 deltas that are working in that pilot to learn and to figure out what makes sense. The data pilot, I think, was Steve Rain's strategic vision, and Lieutenant Colonel Dave Elmo, if you see him in the halls, shake his hand. He's done a lot of hard work to pull that together. So a lot of talent there. We're gonna win by the talent and the humans that we have, and we're gonna accelerate our ability to achieve outcomes by leveraging automation and AI.
So I want to kind of add to that. So Mr. Molikoff kind of touched on it. I think it'd help a little historical perspective, because we've done reprogramming before in the Army, primarily with Duke systems, crew systems, right? Where you would physically download to a CD and mail it to ARAT, and they would give you a new technique, and that would get pushed out across the force on a CD. We're looking at, and so like that process was, about 60 to 90 days to do that update, right? And so we want to update these systems within 48 hours. Right? And so to keep in mind, we're talking about pushing information back to ARAT over a network that may or may not be working at that point in time, right? It's not guaranteed. So it's not like you just logging in your internet or your phone and sending a text message to somebody, right? So when we're talking about the use of AI and the soldiers, and you mentioned 170 deltas, that has to be closer to the soldier who's using the information, right? It has to be closer to the battle than pushing everything back. And so when we talk about this and discuss it, we we throw out random percentages. The one that's not random is ARAT, which is 100%, right? So there's the real experts. They're going to come back to us with a 100% answer, and this is going to work because they had the opportunity to test it in a lab. They had the opportunity to maybe test it over the air. But when we're out in the field, we don't have those, and so what kind of percentage are we looking at that is sufficient for a commander to action, right? So is that 60% if my soldier come back and said, hey, I'm 60% certain it's this signal? Is it 80% certain that it's this signal? How does AI, paired with our soldiers who have been trained to do this, get to those points where the commander can say, hey, great, I can use this now, because we can have all the information, all the data in the world, and if a commander can't act on it, you might as well not have it at all.
Terrific answer. So I'm going to ask a couple more questions, but I want to remind the audience that you have the ability to submit questions as well. You've been here for quite a while, just to go on the AFCEO app and submit it, or you can walk it back to the back there, and they'll ask the question for you. So, Colonel Gorman.
Hey.
Based on observed Russian and Ukrainian tactics and responses, what specific lessons learned regarding reprogramming, speed, and agility are most crucial for the United States Army to implement now to prepare for large-scale combat operations?
That's a big one. I would say some of the observations that I mentioned, like the counter-SAR efforts, and then you're looking at how they're impacting military communications, also impacting commercial communications. I think how we are going to have to get agile with the effects is recognizing that, one, we are in an electromagnetic spectrum operating environment. It is not just EW. And so how we determine those effects based off of the lessons learned when we down select them, recognizing how those are also going to impact our networks. And that is going to be a conversation and a dynamic planning and synchronization required between our EW operators and our spectrum managers. So recognizing whenever we have that effect, that we're going to reprogram on our EW sensor or effectors in this situation, sir, is how is that going to implicate our own communications? And how do we mitigate that at machine speed?
So speaking of that, does anybody want to talk about the counter-drone challenge and what we have to do to modify our EW approach in order to get after the increasing number of drones we're seeing on the battlefield?
So that's a very difficult problem set.
Yes, it is.
And when we look at it, the proliferation of software-defined radios makes this very, very difficult, because not all drones are operating on the same frequencies bands, may not even be on the same waveforms. So to see and identify and create a counter and the amount of time that it takes to fly a drone across the battlefield has to be rapid. And I don't know if that's something that we could do in the next 10 years. Hopefully it is, because it's very important. That is the number one killer right now. It's not artillery, which is traditionally the number one killer, but it's drones. So going through the problem of that is just very challenging.
Yeah, so to Chief's point, just as a point for everyone, there were two major reasons for the successful Ukrainian incursion into the Kursk Oblast region in August of 2024, and it was drones and EW. The Ukrainians had been able to modify their systems, had the latest and greatest software on the EW side, and they also modified the frequencies to support their drone attacks. The Russians were unaware, and it led to a strategic surprise in the capturing of some significant terrain. Okay.
Just to add to that too, I think it's important to realize there's not going to be one silver bullet, I think, that defends against it. It's probably a combination of non-kinetic effects, kinetic effects, directed energy weapons that are really going to be able to handle the entire threat across the board. And then I think in terms of also supplementing or helping that, right, is extending our visibility, with drones ourselves or launch effects, right, having that extended range and reach to be able to sense the battlefield and understand what's out there, what's coming at us, so it gives us more time to react accordingly.
Okay, excellent. One more question, then we'll turn it over to the audience. And Eric, I'm putting you back on the hot seat.
Let's do it.
Okay, so is reprogramming just a government function? If not, who are our partners, and what is industry's role in reprogramming?
So I think I like to tie it similarly to the acquisition community, where there are inherently some government functions in terms of the validation, right? Before we employ something to the soldiers, right? We're not just going to blindly take it, trust but verify, right? We need to validate that and ascertain the level of confidence in that testing before we place it as a capability to the soldier. But there absolutely is a role for vendors, FFRDCs, UARCs, to be able to assist in this technique development. I think also from a training models, from whether it's detection models and or even offensive models, I think those are probably the two biggest areas in which the Army will certainly receive their help. And then even from a data, it was mentioned on several occasions here, the data transport, the data storage, how do we do that most efficiently? The data that is massive currently, and it's only going to grow exponentially, right? How do we trim that down? How do we compress that? I'm sure, I know we've talked in a couple different manners of some technologies out there in that realm, and I'm sure vendors and other industry have additional ideas and capabilities that can help in terms of that storage and transporting and repurposing that data.
Thank you. Anybody else want to comment?
I'll just say when we have hard problems in the tech space, a lot of times the way we overcome that is through abstraction. We build like the OSI model to abstract away. So frameworks, abstraction, help lower the burden, the cognitive burden for the soldiers. I think that those mechanisms will be built and will help us to accelerate in multiple different directions. I think AI gives us a lot of opportunities to go in a lot of different directions concurrently. And I think that'll be able to apply to that problem in particular.
Okay, at this point, I'd like to turn it over to the audience. If we have any questions in the back, please share with us.
Yes, sir. We do have a number of questions from the audience today. The first question, yesterday Major Godbolt spoke on Russia's decades-long investment in electronic warfare. What other initiatives is the Army making to get ahead of the game? And what is your call to action for industry? How can they help you achieve those goals?
Okay, before I turn it over to a panelist, I'm going to throw out a couple things here that I would just want to make sure the audience is tracking. First of all, the Army has recognized the significance of electromagnetic warfare in modern warfare. And so just in March, we released a new Army EW strategy. It's nested with the SecDef's directive for 2025, as well as the Army Transformation Initiative. And we are actively pursuing an implementation plan that will operationalize the goals and objectives within that strategy. Furthermore, the Army recently stood up a 3-star forum, which we like to refer to as the EW Board of Directors, to help oversee the execution of that strategy. And there are heavy investments in training, taking the lessons learned from Russia and Ukraine and rapidly integrating them into our programs of record. At the operational level, we've recently written a MDO range guide, which will allow a platoon leader, infantry or armor to take a regular range and turn it into an EMS contested range to practice their missions control. We're investing in our organizations. So just recently, we made a decision to double the size of our EW platoon at the mobile BCT, recognizing that we need more capability at the tactical edge. We're going to build out 18 EW companies across the divisions, Compo 1 and Compo 2, in the next 5 years. We're even investing in EW capability at the theater level within the multi-domain effects battalion. And Leslie, I'm sure, can talk ad nauseum about the amount of kit that we are investing into the transform and contact units and how we're rapidly learning from that. Experimenting, we're even updating our policies so that they are more aligned with allowing us to reprogram. So a lot going on in this space. Leslie, would you talk a little bit about the material?
Sure, thanks, sir. And this nests very well, I think, well, obviously with the strategy, but to your point about training and how we operationalize EW, because, and I want to give Major Godbold a shout out because he's very steeped in his observations in theater on what's going on. And we took Major Godbold's direct feedback on his observations, along with some of UCRF's G39 observations to really help inform the capabilities and where we want to go with our requirements for electromagnetic warfare sensors and effectors. A lot of focus right now, obviously, on addressing, to your point, sir, getting capability ready and prototyped out for those companies that are going to be that will be operationalized or activated at division, starting around FY28. A capability called TLIS EW, or Terrestrial Layer Systems Electromagnetic Warfare, which will be we're looking for it to be a more modular capability, so that way it can be moved from vehicle to vehicle. I think we're past that point, sir, of we're going to have a dedicated EW vehicle, right? Trying to move across the battlefield, antennas looking like a porcupine. We are really trying to get to a more mission modular payload, because we recognize that electromagnetic warfare is a critical enabler and across all warfighting functions. So that's, we're working very closely with PM, EW, and C to help figure out, to work together what that looks like for those division EW companies. We also recognize that we do need an aerial EW asset, and especially when it comes to EA. And so along with the Army Transformation Initiative, we recognize some of those, the primary or the larger movers, say the Great Eagle, your Type 3, Type 4 class UAS, are going to probably be phased out in the years to come. And so we're trying to work with EW&C on like, hey, what does it look like to potentially put a sensor and effector on a Type 1, Type 2 UAS, get that out in the field, and that ties directly back to Rick's observation, your comments about the UAS and the counter UAS fight and what we're looking at. And then along the lines of modular EW systems is we want to make sure that it's platform agnostic, right? Especially as
Explain that for the audience.
Okay, absolutely. So like I mentioned, no longer we're going to have a devoted EW system trying to trudge along a battlefield, but it is taking a look at what is assigned at echelon to those formations. So say it is that Type 1, Type 2 UAS, or if it may be an autonomous fighting vehicle up on the flat, right? It is developing those mission modular payloads, platform agnostic, that can be, and remember, these are going to be built to standard. As MOSA, right? I think a lot of folks are familiar with the MOSA standard. Along the lines of MOSA, CMOS has been what has been that primary chassis and swap consideration. We recognize that CMOS may be too heavy for your lighter weight UAS. It may be too cumbersome, or that the power requirements on that AFV may be too cumbersome, or for that CMOS chassis to be able to integrate. So with the modular EW systems, we're looking at lighter weight chassis. Think even in some cases dual use EW sensors. You can do a lot with SDRs. And then what can we modify on software on some of these sensors and effectors on the battlefield to get that modularity that can be integrated in multiple fighting platforms.
So Al, with the idea of this platform agnostic approach, would it be fair to say write the software once and apply it across multiple different disparate platforms? And what are the challenges associated with that, and what are we doing to overcome it?
Yeah, that's a great question. That is a hard problem, but I think through code we'll be able to overcome that. We have some industry partners and government partners that are working with us to develop abstraction software that will receive inputs from an operator or a developer that will kind of in a common way instrument the FPGA that's on certain SDRs in a common way. So it abstracts away the complexity, the different hardware architectures of those FPGAs so that a developer has one way to program multiple architectures. And so I'd like to foot stomp what Lieutenant General Barrett said in her talk yesterday, modular payloads. That's what that abstraction layer gets after. It helps us to abstract away a lot of the complexity that comes with different hardware platforms. So yeah.
Thank you. Okay, next question, please. Oh, I'm sorry.
Yeah, I just wanted to add too that not every industry or vendor out there is going to have the opportunity to build the next EW weapon system, but there are still opportunities within the EW domain to be able to contribute, right? So I mentioned data transport, data compression, storage previously, but one of the areas I didn't, as well as model training and so forth. One of the areas I think of very high potential is in the test world, right? So the virtualization, being able to replicate different environments, precipitation, et cetera. That all helps us. Like I said, speed is the name of the game, and so we're not going to be able to go out to the field and actually test these things before we produce the capability to the soldiers. But we're going to have to do it in the labs, and if we can enhance that modeling and simulation, those constructive virtual live environments, that will help tremendously in speed and quality.
Thank you.
So can I say something on this too? I don't want to take up too much time, but so if we're talking about where our adversary is compared to where we are, I look at it from the technology standpoint of when you look at a Tesla, right? All the technology in it is brand new. It operates smoothly. It's fully integrated with the car itself, with the whole system, right? You got full system integration, and you compare that to a normal car. Where they're bolting on these technology pieces, but it's not integrated very well, and it's kind of clunky to operate, right? And so that's kind of how I look at it when we look at our adversaries. Basically, they have this older technology, and it's expensive to upgrade, it's expensive to retrofit and get to that new technology level. And so one of the reasons why it's taken us a bit of time to do this is because we're looking at brand new technologies that haven't actually hit the ground yet. And you're trying to figure out how to integrate that into the system, a full system integration, not just a bolt-on piece to it. And so when we do that, it'll make our technology, evolution, one or two evolutions ahead of everybody else. And this happens all throughout, industry and technologies as you come out with new things. It's more expensive to go back and retrofit and upgrade than it is to start from a new technology standpoint. So we could do things, right? We can go and pull, barrage jamming off the shelf and throw that on something, and there you go, you got it. But that's not the new thing. That's not the best way to do things now, right? We want the new techniques, the exquisite techniques, the new capabilities that are fully integrated across the entire platform, across the entire ecosystem to do this. So yes, Russia has invested decades into this, and the Army hasn't invested decades with an S yet into this. But when we do start putting capabilities out there, we're hoping that we'll have a large advantage to what's currently available.
Great answer. Next question, please.
Okay, thank you. Next question. At what echelon does the panel see reprogramming efforts residing relative to electromagnetic support techniques?
I would say that is, you are going to see the preponderance of it at division for ES. Because if you think about it, I'm not saying that the brigade guys are not going to be able to reprogram, because that, we had the T-less man pack. And during Project Convergence 5, this past year, we saw the early stages of what reprogramming looks like with the subcomponents of the T-less man pack, which was fantastic. It was great to see. But I think when we're talking the electromagnetic support and that characterization requirements, being able to tap into the electromagnetic libraries I think that's where that's going to be heavily resident at division, especially whenever your connectivity will reside largely on SIPRNet, just due to some of the classification concerns. But then think how we push, right, those effects or load them in the arsenal for SPUE usage down at brigade and battalion echelons. Do y'all have any thoughts on that?
Well, I had to add to that in regards to the arsenal and connectivity, right? So it came up, I think, in various discussion here too, is that in wartime, we may not have connectivity. And so it's not a kind of an end-all be-all within the arsenal, right? That has all of it. However, there are elements that will be downloaded, per your region of operation. You don't need everything everywhere. And so that will have access to that. And, I'm not sure exactly what level, but to that effect, we'll have that capability of that kind of on-premise storage and availability to tap back into that, even if in a congested and interrupted environment. So.
And to your point, I also want to make sure that our users out there understand we are, especially Next Gen C2, there is the ability to leverage the tactical cloud, and that facilitates so much of the data throughput, especially when it comes to arsenal and the reprogramming that you're going to see on the battlefield. So it should be, I think, your lower levels or your lowest levels or lowest echelons will be able to take advantage of how they reprogram, especially their man packs and some of the effectors on the battlefield in the future.
That's a great point. And I'll say, I think one of the key factors in that equation is going to be how well we can detect at the edge.
Yes.
The better we can detect, you have to be able to hear really well in order to respond in a dynamic way. And so the more capable we could make the edge for detecting signals of interest and being able to respond in a fairly automated way within certain parameters, I think that's going to reduce the burden across, striated across the different echelons.
Well, certainly, we're still learning in this area. Leveraging the RF data pilot is part of our experimentation. And it probably depends on where we are in the competition continuum. I can see an opportunity where we could centralize a lot of this work, leveraging partners like FFRDC, ARAT, industry partners, when we are in competition and we have more time. But as we get closer to urgent or emergency requirements for reprogramming, then we're going to have to look at pushing some of that capability closer to the battlefield, closer to the edge. So it's probably going to be time dependent, and as we build out additional capability. Today we have a loose conglomeration of organizations that do reprogramming for the Army, and we continue to experiment with a framework with that would allow us to provide a better, more formal governance structure. Anybody else want to comment on this? Okay, next question, please.
There's been some discussion about joint operations across the services. How does this change when we include our coalition partners?
Right. So when you talk about partners, there's different levels to partners, and there's different information sharing agreements that we have with them. But we really need to be able to find a way to be interoperable with whoever we're going to fight with, right? And so what I can share with one nation, I may not be able to share with the other nation, but we need to get down to a point where we understand that some information, regardless of who collected it or where it came from, needs to be shared, right? Yeah. So if I know an adversary's location, if I know an adversary's frequency, that should be able to be shared, right? That's not what we consider classified. Now, it might be classified with the methods and means of collecting that, but we've got to be able to hammer out those agreements and build them into the system so that we're still doing it at machine speed. So we're not doing a swivel chair, handing somebody a Post-it note in the combined joint talk,
yes,
if you will.
And I would say that also, that a lot of that, I won't say magic, but that is going to be a transport layer consideration that I think has been identified early on. We have the means nowadays to be able to declassify and filter information at the right level at the right time. It's not just solely cross-domain solutions, right? We have the ability to do that now. But to your point, it is working with those countries to ensure that the policy considerations, what the requirements are at echelon, that they're addressed, and then how we include that in the reprogramming enterprise.
Chief, can you expound on what we're trying to do with the security classification guide to help with this problem?
Right. So we did a research study of different security classification guides, and we didn't find a guide that specifically addressed data. The closest we got to it was there's a guide that IEWS has that really addresses more of a test and experimentation, not so much an operational flavor. So when we're looking at this, we need to be able to come down and say, look, some information is classified. Some of it's secret, some of it's top secret, and it is for good reasons, right? But then there's other information that is classified as secret or top secret that shouldn't be classified at all, and is classified solely based on the system that collected it, right? Which doesn't make sense because all of those guides now are saying that we're classifying information based on a system, right, and not the information itself. And we need to be able to classify information itself. And we also run into other issues with original classification authority, which is based at the is held by the combatant command. Well, if INDOPACOM sees a system and classifies it as, say, top secret, and CENTCOM sees the exact same systems, the exact same information, and classifies it as secret, it's the same system, right? Because we're not the only nation that sells, capabilities to other nations. So that becomes a problem where it's not just, sharing data between partner nations, it's sharing data across combatant command boundaries.
So if I heard you correctly, what we want to try to do is classify the information at the data level rather than based off the platform that collected it, so that we have a common understanding, and that might help with shareability.
Right, absolutely. It will increase shareability, and that goes back to the opening comments that regarding like a data standard and being able to standardize the language and share that. You got to have the same classification levels for that data.
Next question, please.
Can the panel speak at all about any plans to incorporate AI into the next generation ISR platforms, for example, the Hades Athena programs?
Al, you're our AI guy.
Well,
Would you like to address that?
I'm probably not best suited to address the ISR platforms at this time, unfortunately.
Okay. Given that this panel is on reprogramming and not on intelligence systems, we're going to move on to the next question.
Sorry.
Yes, sir. And this is the final question that I have from the audience, after which we'll turn it back to you for any additional statements. Can you speak at all about the approach to deterring China and what obstacles you might see in that approach?
Colonel Gorman, you want to start us off?
I would go back to my comments that, look, one, tyranny of distance and time, right? Where there's a lot of real estate in the Indo-PACOM region, right? We have fought multiple wars on large swaths of land. However, what we're facing in the Indo-PACOM region is very unique. There are multiple countries that are resident in the Indo-PACOM. They all have different communication considerations. Not only their military communications, but their civilian communications. We also are facing an adversary that has spent probably the past 30 to 45 years observing every move that we do. And I will leave it to a certain point here, but there are certain socio-cultural policy considerations that also impact electromagnetic warfare information and operations and our ability to reprogram. And so the adversary has watched us very closely. They've seen how we have executed our missions in CENTCOM. They are able to observe what we observe, right, in the Ukraine-Russia conflict and what we do in our own homeland. And so I think these are all some considerations that we have to understand. I certainly take it into consideration as the user representative for electromagnetic warfare and those capabilities of, hey, what do we need for a capability out on the battlefield that we can directly get into that adversary's decision cycle, cause confusion, cause diversion, and if we need to, fully deny them their ability to communicate using electromagnetic warfare tactics.
Eric, your thought?
Yeah, you just hit on what I would have run through my mind in terms of one. I think EW is a great deterrence, right? It's in the non-kinetic realm, but the confidence, like deterring their confidence, is enough to deter actions, right? Mm-hmm. And I think that the obfuscation and the decoys, right, and then that undermines their confidence of them understanding where we're at and what truly they're seeing, could potentially be enough to deter certain actions.
Al?
I think the bottom line is being able to wield data in a dynamic way to outmaneuver them and get ahead of their decision cycles is the key.
And Chief Godfrey, the last word.
So I would say that the Army traditionally is one size fits all. And I think that we are now recognizing that what is needed in Indo-PACOM is not necessarily what's needed in EUCOM or in CENTCOM. And so I think taking that approach of, I don't want to say they're exquisite or special capabilities. It's just building capabilities that are better suited for those environments.
Well, China is certainly our pacing threat, and we are fully focused on trying to meet that challenge. I want to take this opportunity to thank our esteemed panelists for your time today and your great thoughts and comments, and thank the audience for your participation. This concludes Reprogramming for Resiliency. See you next year.
Thank you.
Thank you, gentlemen. Please welcome Tim Reyna back to the stage.
Dave and panelist members, thank you for today's words and thank you for discussing this with us. I just want to say thank you for doing this, and in lieu of a speaker gift, sir, ma'am, and gentlemen, we're going to make a donation to the Signal Corps Museum, and thank you for doing that. For the audience, we'll be taking a break from here till 4 o'clock, so we encourage you to go see the vendors on the floor and network with the people that are here today. Thank you, sir. Thank you, ma'am. Gentlemen.